I think what I'm going to speak about is a very small layer of paint on top of a very tall structure, and it's the current, it's the here and now, and I've been sort of taking little notes as we went along from the day that this tower is built on a lot of deeper understanding from the past and learning from each other and the value of tools and communication and sacred rituals and social memory and settlement patterns and living together densely in the state, and of course energy, and then informality and inequity. We have to view what I'm talking about within that context, that foundational work. So we also, I'm going to try and be optimistic in light of Barnabas, but we really do have to understand that climate change is a fact, and that it has physical, social, ecological factors that are seemingly insurmountable. They're frightening, and I won't reiterate the facts that he went over, but they're frightening, right? It's 1/3 of our energy is coming from buildings and building operation, but the important point here is that we can reduce the building impact on climate if we recognize this fact that it is an area that really can make a difference. So I first want to really touch on this tremendous pace of technological development. One generation ago, when I was a kid, really, there were very few computers, no smartphones, no robotics, and the past 20 years has been astonishing. And what's maybe ironic is the next 20 years are really going to make the past 20 years seem like nothing has happened. I think the Human Development Index here measures countries' social development in 3 areas: health, education, and standard of living. On the right is the population index, which is almost running in parallel. Here we can see the first machine age and the second machine age, which is computational technologies, and they're almost running in parallel. But most predictions, including the UN, are that our population will peak at about 10 billion people by the year 2100, maybe even sooner, maybe later, but that's kind of the ballpark peak at this point. My question is, what happens to human development with the declining population at this point? And my optimism tells me that we don't make more things, but we make things better. And I challenge you to consider not only how our buildings or environments are made or how they look, but really rather what they do, how they can do it in an adaptive, responsive, and of course an ecologically responsible way. So the first sort of trajectory here is that they can mediate. They can mediate and act as an intervening agency. I'm going to show you a couple examples. This is just the KFW West Tower by Sauerbach Hutton. It's an active facade. It's defined as a whole structure combining performative technologies. They're both tectonic and atmospheric considerations. Here's another example, Al-Bahar Towers. In this case, the skin changes throughout the day, literally that as a living adaptive and responding poetically to both cultural and environmental forces. This is a project of ours. It's a wedding hall in Israel that basically morphs and spatially adapts to different programmatic scenarios. This is just an art project, but it spatially adapts to depending on the use. So if there's an unoccupied space, then the volume of the site is slowly filled in. More activities opens up the space, making it more navigatable. I threw this example in because I think it's interesting. This is Smart Highway by Studio Rosegaard in Netherlands. But the innovative point here is that the roads themselves, not the car, are what take on the intelligence. And typically we've kind of dealt with when discussing highways, we discuss with making more intelligent cars. And the point is that it kind of repositions the role of the designers thinking about the possibilities of the environment itself, mediating at a really large scale and not just the objects within the environment. The second is looking at things that can evolve. And responsive systems have the ability to transform the response to changing conditions. So these are decidedly no-tech approach. This is by Akim Menges. It's basically a project made out of wood that has hygroscopic behavior. Basically, it absorbs moisture from the air, and during absorption and desorption, there's a physical material change. So it's kind of looking at kind of how things are adapting and responding in nature, applying it at an architectural scale. Another example of the same type of process, this is by Doris Sung at USC. This is a Bloom project, but it's using thermal biometals, basically making another dynamically responsive skin, basically with the goal of self-regulating building temperature. And I want to point out that most of our problems are really technogenic. They're created by other technologies. Part of this is because what I call autocatalytic process is a chemical term, but in this case it means the pace of change accelerates because digital technology reinforces the development of innovative products. So the process kind of cascades. And to make almost everything, I think, in this space, right, it relies on an ecosystem of other predecessor technologies. It's really hard to evolve forward. And so I think this is also affecting architecture quite a bit. The frontiers of fabrication have increasingly embraced like more of these biological and even sustainable agendas. And, you know, research in digital fabrication, opening all sorts of possibilities constructing in our world, you know, in a completely different, even formal way. Things that are lighter, cheaper, less energy using materials, increased efficiency, minimal errors, et cetera, et cetera. And there's many architects who are just coming to terms with these new tools that we've basically appropriated from other industries. We're starting to understand that they're no longer tools just for making things, but they're really tools for thinking. We can approach design completely differently because these tools are involved in the actual construction. It's these predecessor technologies that are enabling new ways of thinking. I have a little stand-up bass there. It reminds me of a story. Last night I was arrived very late because my kid had a concert. He plays stand-up bass, and he's okay. He would do okay without playing this music, but the thing is, he played, his orchestra played last night with this piano prodigy, and it was so fantastic, so moving. Just a kid, and I think about this slide here, in that, you know, if these orchestral instruments had not been fostered to be developed, Grieg would not have been able to write the concerto that this kid could not have been able to translate through his fingers for the audience. And like, what a kind of disservice to humanity. I wonder if this kid were born at the beginning of that timeline far away, like what his brain would have been disposed to. And so from an architectural standpoint, like, to embrace these, I think, can have very positive effects if we learn to sensitively embrace them. So the work in 3D printing and concrete is also poised to make a massive impact. Is just another thing I wanted to mention. Barnabas mentioned concrete. I think it's very important, and I'm going to say a point on it right now, because we're seeing this shift from mechanical to biological in terms of adaptation in architecture. And I think there's a lot of research in materials. We can theoretically now produce materials to meet any specific performative criteria. And another icon to tell a story, because I think about the light bulb, right? And as a metaphorical idea that you know, lights are part of a huge energy problem in architecture. And typically in the past, we have massive HVAC systems to overcompensate for the light that is generating so much heat that we need in order to live and work in our buildings. And then the LED was invented, which became like really sort of a signature. Every one of these lights in here are LEDs, and they're using a fraction of the energy. In fact, 95% of their energy is light, not heat. And I think that this symbolizes a way that we need to approach utilizing these technologies to look at innovative ways of not using less light, but rethinking how we create light. Okay, so with this background, we get to what's really my thing. The age of calm technology is really here, that all of this technology is receding into the backgrounds of our lives and to architecture, and that we kind of rely on the convergence of embedded computation and the physical counterpart, and these together satisfy adaptation. A little slide here to sort of look at the evolution of robotics. In the recent past, this is pick-and-place robotics, moving towards modular robotics, moving towards the scaling down of robotics, and towards biohybrid and soft robotics. And I think there's in this move towards ubiquitous computing or pervasive computing, we have computers in everything already, but they're still quite obvious. And I think this scaling down of computation is what's going to really change the way we interact with the world. And I think technological success might be defined somehow as no longer having to think about it, right? We have electric lighting in this room, but nobody thinks about it. We take it for granted with this understanding of technology embedded into our environments. So this is, I've done a lot of exploration in this area of biohybrid robotics, so combining biological living materials such as plant and animal stuff with the robotics, and you get a sort of robotically augmented biomimetic adaptation. And the last sort of, well, not the last, but almost the second to last thing I want to talk about is communicating and how these environments, how our buildings and our environments can communicate. And I think a subtle but important shift has started to take place from the tectonics of techniques and methodologies towards broader questions about social and cultural issues, a lot of what we've heard about today. In these couple of projects, both in Hong Kong, they have been on making environments which allow us to illuminate, or the projects themselves would illuminate unnoticed or invisible phenomena. And they're all the more powerful, I think, because they teach us about something we might not have been aware of or could not, in fact, perceive through our senses alone. This sort of, that the architecture can augment our perceptual understanding of data, of what's going on. And there's all sorts of different interpretations, but things that we can sense not through our kind of normal sensual palette, which is pretty limited. And so our changing sort of reality in how we interact with our cities is moving quickly from interface design to augmented reality, virtual reality, and we're starting to understand how people can control their environments. And we heard earlier from Michael about different types of communication and gestural. And I always think that it's interesting. We've done a number of research projects. How we interact with our digital voices is really all sorts of gestural interactions. But with our buildings, it's somewhere between voice, which will likely prevail, but also gestural stuff. And I think there's a lot of these gestural interfaces still in their interfacing sort of infancy, but they do show like really fascinating promise of how we communicate with our environments when they get embedded with intelligence. This is another, we've done a lot of these sort of projects with students in the past. So I want to talk a little bit about AI now, and AI is incredibly profound. I it's hard to even articulate like the future of it, but it is going to be in everything and every aspect of our life. And so I think architecture is one small area. First off, I think there's not AI, but there's many specific AIs, right? And they are all specific task-oriented artificial intelligences. And I think there's a few questions that this brings up when you start having these sort of responsive, interactive architectures and environments that are then enabled with artificial intelligence. Can a building environment change our behaviors? If so, in what ways? And I think it's important kind of ethical questions. There's a direct relationship between the benefit of any system and the amount of data it has on us. And like, do they create cognitive atrophies? I think of the way our skills like remembering phone numbers and have atrophied because we don't call people by their phone numbers anymore. You simply use things differently. And the last issue I think is probably the most important. It has to do with privacy and tracking. And you know, there's self-tracking, there's co-tracking, there's tracking by governments, there's tracking by businesses. There's really no end in sight. And yet there's a direct relationship between the benefits of these systems and the amount of information that they have. And I think there's a strange sort of generational acceptance of understanding and accepting these trade-offs that previous generations didn't have. And these things that we use like health data and shopping data and navigation. And yet today we've come to embrace the new technology, every new technology with the promise, and it's perhaps illusionary, but the promise of convenience, but for the most part without the fear. And the fear might be there, but it's something that's understood and accepted. And so with AIs, they are great at optimization. They have many potential impacts in architecture. They're going to revolutionize pretty much everything. And you can already have AIs that can deal with many site factors like wind, noise, sunlight. Architects can design, and they can optimize this data. And I think AI can do extraordinary things beyond the capacity of the human mind. It's really transcendent relative to the human mind. AI can solve incredibly complex problems, data mine and assimilate, calculate on orders of magnitude beyond our comprehension. And as previously described, they can self-evolve through deep learning, yet it cannot invent its own rules. At least for now, it cannot transcend its own programming beyond emulation to match that of the human imagination. I point this out with Move 37, which was a famous Go move in which AlphaGo demonstrated something akin to creativity. And I can tell you about Move 37 later. But the growth is exponential in terms of data being produced. And the conundrum here is the energy necessitated by the AIs for all of these applications. But AIs are not really about intelligence, but they're about data processing. And the thing I want to point out here is that AI is really, in architecture, a bottom-up generational aspect. And it is very good at this. What is still needed, at least at the current moment, is the curatorial and editorial value of the humans. And so they are very good at generating ideas, making us think of things we might not have thought of ourselves. And so the last part is catalyzing. What it can do is reposition the role of the designer, not to create a finished design, as to catalyze a design, to acts that can evolve. And so I want to point out beyond this aspect of computational catalyzation is when AIs or humans can build upon what was catalyzed by humans, they can become adaptive in real time. This is a project by Arvana where the skeletal architecture is built to a certain extent and it's then catalyzed so that people are then capable of building on top of it. And So this can work either way, that the AIs can catalyze or the humans can catalyze. To come full circle, the bottom-up generation of AIs can be curated by humans to create a data-sourced, environmentally conscious, code-compliant, sort of skeletal-built architecture, which can then serve as a catalyst for social and participatory design-build architecture for the people to carry out. And this can work both ways. I'm super optimistic as a protopian, and this is a future where life improves gradually over time rather than being a utopia or dystopia, and this is through realistic approaches to issues. And so we see my kid there on the left. These technological built worlds are like full of vast amounts of information. They're social, they're interactive, and they're creating a new techno-literacy that we really don't even understand, but will eventually only understand through use. And it's not the end, it's not even the beginning, but it's perhaps the end of the beginning. So on the last slide, I just want to say that, and this kind of goes back to the first slide with the graph, that reflecting on the Copernican sort of idea revolution that humans are not the center of the universe, moving on to the Darwinian idea, we may be distinctive, but we're not animals, and the cybernetic revolution, maybe this is human-computer interaction rather than cybernetic, I don't care what you call it. It's this symbiosis of humans and AIs working together, but we need to understand that they're much smarter than us. They will continue to get only smarter, and they're not sentient, or they're conscious or self-aware, and I don't think they need to be, or even that it matters. What matters is that they are nascent, and that they are basically, we need to learn how to live differently. We need to learn how to work with AIs to augment who we are, to learn how to do things differently and how to think differently. And I would just say in closing, I'm incredibly optimistic that enables us to think differently, see things we might have seen before on our own, and there's an acceleration of learning that happens by being exposed to more and different ways of seeing things. Sorry, that was a little long. Bye, thanks you.